Good morning. In this session, we are going to talk about taking next step in your database modernization journey. We will walk through the benefit of moving to AWS open source solutions and how to migrate from Rds Oracle to Rds PostgreSQL or Aurora PostgreSQL compatible database. My name is Krishna Sarabu. I'm a senior database specialist solutions architect at AWS. I'm joined here today with my colleague, Joseph DiCaro, who is also a senior specialist solutions architect at AWS. So without the further ado, so let's move on to the agenda. So here is our agenda for today's session. We'll start with why customers are migrating to AWS PostgreSQL solution and the migration tools that can help facilitating the database migration. And also we'll look into top 10 best practices before starting the migration. Finally, we will discuss various migration programs that can also help you to move from Rds Oracle to Rds or Aurora PostgreSQL database. So let's start with why migrate from Rds Oracle to Rds or Aurora PostgreSQL. The first reason the customers have given us is that they see load costs and of course no licensing requirements for open source databases and not to worry about vendor lock-ins. And another reasons customers looking is for the simplicity and innovations available with open source databases. PostgreSQL offers a large number of extensions by the community to address many features needed by the customers. They see the features such as extensibility and database projects moving much faster, and they wanted to take advantage of that. At the same time, they also see open source platforms as being a lot simpler and easier to manage. PostgreSQL community is really active and has very good track record of being responsive to what their end users asked for, and to adding those cool new features to PostgreSQL platform on a very consistent and regular basis. Also, PostgreSQL is most compatible open source database for workloads from Oracle. So let's now look into the existing state of commercial databases. So this data was collected from two sources, and as per dbengines.com, which is on the left-hand side, the usage of open source databases has been overtaken from the commercial databases since 2021. And on the right-hand side, as you can see, the data was collected from Stack Overflow Developer Survey 2022. The top leading and popular open source database is PostgreSQL, just by a few decimal digits over MySQL, if you could see, right? So now that we looked into the existing state, let's look into modernize and migrate Rds Oracle to Rds PostgreSQL or Aurora PostgreSQL. So let's start with Rds, Amazon Rds PostgreSQL. Couple of slides ago, I mentioned that the customers are telling us they believe PostgreSQL is the most compatible target for most of their Oracle workloads, and this slide goes into some of those reasons. First, of course, is open source project, and it's been around 20 plus years. With Rds PostgreSQL and Aurora PostgreSQL, you get the same experience as Rds Oracle. They are fully managed, and that takes care of your time-consuming database management tasks and frees you to focus on your application. Fully managed databases at AWS offers you push-button scaling, automated patching, automated failover, backup and recovery, isolation and security, and advanced monitoring. Rds PostgreSQL and Aurora PostgreSQL compatible databases are highly secured, and you can encrypt data at rest and also encrypt while in transit. Both RDS and Aurora PostgreSQL supports various authentication mechanisms. And in addition to that, you can also use Kerberos to authenticate users when they connect to your database instance running on PostgreSQL. In this case, your database instance works with AWS Directory Service for Microsoft Active Directory to enable Kerberos authentication. Like Rds Oracle, Rds PostgreSQL also supports multi-AZ deployments for high availability to protect your primary database instance from failures and as well as disruptions in availability zones. You can use RAID replicas in same or across regions for disaster recovery and also to scale out your RAID-intensive workloads. You can create up to 5 RAID replicas from one source database instance. And as of RDS for PostgreSQL version 14.1 or above, you can also create up to 3 levels of RAID replicas in a chain, nothing but the cascading replication from your source database instance. So that will give you a maximum of up to 155 RAID replicas per source instance. So Amazon RDS PostgreSQL supports the latest version of version 14. So this latest release adds to PostgreSQL's trend on improving high performance and distributed data workloads with advances in connection concurrency, high rate workloads, query parallelism, and logical replication. Version 14 also include innovations on complex data types, including more convenient access for Json and support for non-contiguous ranges of data. Another reason why PostgreSQL is more popular choice for its feature-rich for developers than Oracle. It supports various procedural languages including PL PGSQL, PL Perl, etc., and various foreign data wrappers for accessing external data sources such as MySQL, Oracle, and SQL Server, and including Postgres, of course. And PostgreSQL has around 64 base data types and can be extended for more. It also supports data types such as JSON, JSON-B for binary JSON, and spatial data. More importantly, PostgreSQL is designed to be easily extensible. So for this reason, extensions are loaded into the database and they can function just like features they are built into the core Postgres. RDS PostgreSQL and Aurora PostgreSQL supports popular extensions such as RIFC, pgportman, pgcron, PostGIS for spatial data, and of course various foreign data wrappers I mentioned as earlier. Right? RIFC extension, it provides functions and operators that emulates a subset of functions and packages from Oracle database. So this extension makes it easier for you to port Oracle applications into PostgreSQL. So let's now review Aurora PostgreSQL features. So let me start with RDS and Aurora PostgreSQL comparisons and when you should be using Aurora. With respect to PostgreSQL open source engine, you get the same feature as RDS on Aurora and more. In fact, more features. For example, Aurora PostgreSQL has additional features such as cluster cache management between writer and reader node, and query plan management, so where you can pin your execution plans, something similar to Oracle's SQL plan management, and of course data activity streams for your auditing requirements. And in addition to that, it also gives you integrations with other managed services such as Amazon S3, AWS Lambda, and AWS machine learning services, SageMaker and Amazon Comprehend. When to choose between RDS PostgreSQL and Aurora PostgreSQL, higher concurrent workloads, they tend to scale better on Aurora compared to RDS. And Aurora is optimized for higher throughput and highly scalable for OLTP workloads. Aurora's shared storage model and cross-region replication architecture is ideal for applications with low RTO and low RPO requirements. So with that, I'm gonna now start looking into Aurora's architecture. Amazon Aurora is a MySQL and PostgreSQL compatible relational database that's built for the cloud. So it combines the performance and availability of traditional enterprise databases with the simplicity and cost effectiveness of open source databases. At core, Amazon Aurora decouples your database compute and the storage. Aurora uses purpose-built distributed storage layer which stores your data across 3 availability zones. So we keep 6 copies of your data across 3 availability zones and 2 copies in each. And depending on the size of your database, your data is striped across hundreds or even thousands of storage nodes. So with that, what you get is better availability, durability, and performance. Aurora storage can scale up to 128 terabytes, whereas Rds PostgreSQL supports up to 64 terabytes. And another important factor is Amazon Aurora storage is also a self-healing. So that means the data blocks on the storage layer and of course the disks are continuously scanned for errors and repaired automatically for you. You can also add up to 15 low latency read replicas to the same storage volume in addition to the writer node. And you can use these reader nodes to scale out your read intensive workloads. And most importantly, because there is this separation of compute and storage, you can scale compute separately and independently of the storage layer. So you can scale it up and down, add more read replicas, remove read replicas, without having to worry about what's happening to the storage layer. So all right, now move on to the next slide to review Aurora Global Database. Amazon Aurora Global Database, it is designed for globally distributed applications, allowing a single Amazon Aurora database to span into multiple AWS regions. So it replicates your data with no impact on database performance, enables fast local reads with low latency in each region, and provides disaster recovery from very rare region-wide outages. So an Aurora Global Database has a primary database cluster in one region, and you can add up to 5 secondary database clusters in different regions. And you can scale up each secondary cluster independently by adding 1 or more read replicas to your to serve read-only workloads in secondary regions. So I'll now move on to talking about another Aurora feature, which is Aurora Serverless V2. Aurora Serverless V2 features on-demand and auto-scaling configuration for Aurora database. And in this configuration, your database compute capacity is automatically scaled to meet demands of your application. Of course, you only pay for the resources you are using at that point in time instead of paying for the peak capacity. With Aurora Serverless V2, the capacity is adjusted instantly and in a fine-grained increments to support even most demanding application workloads. So now that we looked into RDS and Aurora PostgreSQL features and why PostgreSQL is a better choice for Oracle, so let's now discuss the migration options from Rds Oracle to Rds and Aurora PostgreSQL. So I'll now pass it over to Joe to talk about migration options. Joe, back to you.
Thank you, Krishna. Let's jump right in with migrating from Rds Oracle to Rds PostgreSQL or Aurora PostgreSQL. What we see is that customers don't have just one database and application pair, but have many combinations. As part of their approach, they first go through an assessment and inventory phase to classify migration patterns and prioritize migrations, as in step 1, as you see on the screen. Customers assess and determine to switch the database engine from Oracle to PostgreSQL The goal is to evolve from Rds Oracle to Rds PostgreSQL or Aurora PostgreSQL and begin their analysis. Then they work to convert schema objects in code. Customers then migrate their data from the Oracle engine to the PostgreSQL engine. They test and finally cut over production. So at a high level, that is what migrating from Oracle to Postgres typically looks like in the real world, and it starts with a comprehensive assessment. In steps 4 through 10, we are diving deeper on the approach to what an Oracle to Postgres migration really looks like. It is more than just switching from a commercial database and moving to an open source database engine. That's because databases are tied to applications. There are table structures to consider, and there are many, there may be database code objects like store procedures, functions, and triggers that all need to be converted. The application will have SQL calls embedded in it, and that could be Oracle specific, for example, Oracle decode statement. And the application will be using an Oracle driver or client that will need to be changed. So when we migrate to Rds PostgreSQL or Aurora PostgreSQL, in addition to switching database engines, we will need to perform additional steps like convert the schema tables and data types along with any code objects into their Postgres equivalents. Next, the application will very likely require SQL statements to be converted. And if they use specific features or functions, they will need to be converted to an ANSI standard Postgres compatible implementation. You will then need to copy or migrate the data from your existing Oracle tables to the Postgres target tables. The client or driver will need to be replaced with a Postgres driver, and of course, thorough application testing in the non-prod environments is necessary to ensure both functionality and performance meet your goals. Finally, planning for a production cutover event is required, and you will need to ensure that the latest database updates are written to the Postgres target database before cutover, and plan to accommodate a downtime window. The downtime window is often desired to be near zero, so the process to switch over should be rehearsed using migration tools that keep the target Postgres database in very close synchronization before stopping the source Rds Oracle database and redirecting the application to Rds PostgreSQL or Aurora after the final updates have been transmitted. So one way AWS can help is by providing tools to automate the migration as much as possible. There are two most commonly used tools that AWS provides for several, but not all of the migration steps. First is the AWS Schema Conversion Tool, or SCT. SCT provides a database migration assessment report that summarizes all of the schema conversion tasks. SCT will list both those that SCT can convert on its own, as well as detailing the action items for objects that can't be converted or can be partially converted by SCT. So SCT will convert many of your databases and code objects fully and automatically as listed under steps 4 through 6 on the screen. SCT can also be run against your source code to both convert embedded SQL and to flag any SQL that requires developer attention. For example, if an Oracle-specific operation were used that is not available in PostgreSQL, like the Oracle decode statement mentioned previously. While SCT addresses the conversion of the schema and source code, it does not move data from the Oracle tables to the Postgres tables. For data migration, we use the AWS Migration Service, or DMS for short. DMS can do an initial full load of your data along with some minor transformations, and can also be run in change data capture, or CDC mode, to continuously stream changes from Oracle source database to the target RDBS Postgres or Aurora PostgreSQL database up and until the moment you cut over. SCT is focused on heterogeneous database migrations like Oracle to Postgres. And SCT can help estimate the level of effort, as well as performing some of the actual migration itself. SCT is feature-rich and provides you a secure way to connect and convert your commercial database schema to an open-source engine. SCT is the first step in your modernization journey to RDS PostgreSQL or Aurora PostgreSQL. We want to define SCT best practices around assessment and database object and code conversion. First, a best practice is to use SCT's multi-server assessment feature to ease the assessment of a large number of databases. This will help you understand the complexity, effort level, and help prioritize your migrations when there are many databases involved. SCT's multi-server assessment feature makes it easier to run assessments against multiple databases and schemas. Another best practice is to not only view the assessment report on the SCT console or in a PDF, but also to save the assessment report using the CSV option. The reason is all of the raw data on the conversion effort, the number of stored procedures, triggers, the status of conversion, the listing of issues encountered, all can be tracked and reported on in a spreadsheet or even a database if you choose. The CSV will help you in the assessment phase to classify and prioritize which databases to migrate first. In the reference slide at the end of this presentation, there is a link to the SCT documentation on how to save the assessment report as a CSV. In addition to very good blogs on the topic of categorizing and prioritizing migrations when you are migrating many databases to open source database targets like PostgreSQL. Be sure to save the output after you run an assessment in your preferred format. Remember that saving your assessment output into a CSV will allow you to create custom reports using your preferred tools and can be used with your classification algorithms. Now let's talk about conversion phase best practices. SCT will attempt to automatically convert as much database objects and code as it can, but there are often areas it cannot convert that will require manual conversion. If this happens, a best practice is to not treat the target like the source. Oracle and Postgres are similar in many ways, but they do have differences. Understanding these differences will help you be successful with your database object and code conversions. For example, Postgres by default assumes lowercase for table names in its data dictionary. That is, if quotes are not used. And this is the exact opposite of how Oracle treats table name case, which is uppercase. In the reference slide at the end of the presentation, there is a link to the SCT User Guide's Best Practices section for more detailed guidance on how to manage your database object and code conversions, like in the example above, as well as many others. Additionally, a key document I want to call your attention to is the Oracle to Aurora PostgreSQL Migration Playbook. This playbook is a detailed document that will likely address any conversion issue you might encounter. On this screen are a couple of pages from the playbook covering how Oracle stores and manipulates JSON documents and how to do similar functionality in the Postgres database as an example for you. The playbook is a must-have document. You can really think of it as your companion document to the schema conversion tool. Here are a few final best practices for the schema conversion tool that I will leave with you. First, use the latest version of SCT. We update it multiple times a year, and each new version increases its ability to automatically convert more database code objects, thus reducing the need for manual conversion. Be aware that if you are working with a database that has a large number of data dictionary objects, like many tables and PL/SQL, you will likely want to increase the SCT memory settings. And finally, be aware of the SCT log and its location, which can give valuable insight on any issues you may encounter, like why a conversion may be taking a long time. On the screen are links to SCT and database resources. Also, in the reference slide at the end of this deck, we've included links to the playbook as well as other migration playbooks. In addition, the reference slide includes documentation links to SET's multi-server assessment feature and using the CSV file option from the previous slides. We encourage you to search the AWS database blogs, which frequently cover migration topics and may well address your given use case at any time. So that finishes our SCT discussion for the moment. We will next turn our focus to the AWS Database Migration Service. Since DMS is a managed service, that means you can start your migration in minutes, compared to spending possibly days installing and configuring replication software on servers in your environment. You can keep your source and application database running by configuring DMS for ongoing replication using change data capture or CDC technology to read the source database logs. DMS can be configured to replicate from Oracle RDS database to RDS PostgreSQL or Aurora PostgreSQL. DMS works with a variety of source and target databases across both open source and commercial databases supporting either homogeneous or like-to-like databases or heterogeneous or differing source and target database migrations, like the Oracle to Postgres migration we've been discussing. Additionally, DMS can support non-relational sources and targets as listed on the screen, including to and from Amazon S3 object storage, NoSQL databases like MongoDB, Amazon Document DB, and Amazon DynamoDB, as well as other Amazon purpose-built databases and streaming services. This slide describes a typical production migration from Rds Oracle to a target Postgres database, which involves starting a DMS replication instance shown in the large center box. DMS connects the source and target endpoints. It then performs a full load from a source to target. After the full load is complete, use change data capture or CDC to replicate ongoing changes. At steady state, take a brief outage, validate, and redirect connections to the Postgres database. As a DMS best practice, first be sure to reference the Oracle as a source chapter in the DMS documentation, because documentation includes how to set up the Oracle DB, ensure the appropriate logs and logging are enabled and available, and what permissions to give to the user that DMS uses to connect to your database. There is also a very useful SQL Plus script in the DMS documentation that is a best practice to run as a pre-check, which will provide an HTML formatted report with key recommendations. This script will collect information on your database that can also be used to help troubleshoot any issues with the DMS service. The user guide provides script execution privileges and guidance to run the script. If your database contains large binary objects or LOBs, DMS provides a few configuration options that affect how LOBs are migrated. These settings provide different migration behavior and performance characteristics. To make these configuration choices, like should you use limited or full LOB mode, it is important to know more about your LOBs, like how many and what size are the LOBs, and do the tables with LOBs have primary keys. Using the queries above provides the answers to these questions and allows you to configure the DMS LOB settings optimally, which can greatly speed up replication of tables with LOBs. There is the table mapping area of the DMS console, and then there is the richer capability of using Json table mapping. Using Json is the best practice for table mapping. Json table mapping allows configuring rules to specify the source schema, data, and any transformations that should occur with the migration task. You can use filters to specify data that you want replicated from table columns and use transformations to modify selected schemas, tables, or views before they are written to the target database. A common best practice is to replicate tables that have many rows in parallel to speed up migration. You can do this by configuring parallel loading, which will migrate the table using several threads in parallel. AWS DMS does this by splitting a full load task into threads, which each table segment allocates to its own thread. First, allow time for the setup. Successful migration will involve a number of layers and components, so allow yourself time to work through any issues that might be specific or peculiar to your individual setup. Second, allow yourself time for dry runs. A dry run helps you understand the timing of the steps of a migration so that you can better plan your production cutover. AWS support is very helpful, so keep it in mind. They see a lot of different configurations of source databases, so they have good experiences to help you get DMS configured for your source environment. Understand your migration scope. Be aware of the things that DMS does not migrate, like stored procedures and sequence values, for example. During the full load phase, the tables are loaded out of order. Thus, you should disable foreign key constraints on the target. Also, during the full load, secondary indexes should be disabled because they can slow down the table replication. You should also disable triggers. And then you can add all these back to the target after the full load is complete. Also, don't migrate things you don't care about. Do you really want to migrate lobs versus storing them in Amazon S3? The blog link on the screen has a good discussion of these migration scope topics. Finally, there are many possible migration scenarios on premises to AWS Cloud, the multiple combinations of source and target databases DMS supports, the large number of possible heterogeneous migration pairings, the use of change data capture, replication streaming, and many database schema configuration choices customers can make. As a result, things can go wrong, so we provide a 3-part blog series on DMS troubleshooting that you can take advantage of. In addition, we have provided a link to the Aurora PostgreSQL migration playbook to provide an overview of SCT and DMS, as well as feature mappings between Oracle and their Aurora counterparts. Again, as a reminder, the playbook is a must-have document. You can really think of it as a companion document to SCT and DMS. I will now turn it over to Krishna to discuss top 10 best practices.
Thanks, Joe, for the insights into SCT and DMS and the best practices. So now let's look into top 10 best practices when migrating your workload from Oracle to PostgreSQL. Of course, the tablespaces is the first one to go, so we'll start with that. Tablespaces play a key role in Oracle databases. A tablespace in PostgreSQL is just a directory containing data files. PostgreSQL creates separate data file per segment. A segment could be a table, index, metallized view, etc. So when a table or index exceeds 1 gig size, it is divided into, typically PostgreSQL divides them into gigabit size segments. So the first segment's file name will be same as the file node, and subsequent segments are named as file node .1, .2, etc. So this arrangement avoids problem on platforms that have file size limitations. PostgreSQL has no real benefit unless the database distributes its data files across multiple mount points and of course into different devices. However, this can be done just as well or even better by striping on a lower level. So with RDS and Aurora PostgreSQL, the table spaces are available for the compatibility, but they add no real benefit. So with that, let's look into the second one, which is index types. PostgreSQL supports more and different index types than Oracle. PostgreSQL provides several index types, than Oracle, including B-tree, which Oracle supports as a default. There are hash indexes, gist indexes, SP gist indexes, and brin. Each index type uses a different algorithm that is best suited for different types of queries. Similar to Oracle, PostgreSQL default index type is B-tree, which fits most common situations. B-tree indexes are typically self-balanced and maintain sorted data. So when query is searching through the index for a given key, it typically makes traversing to any branch or leaf block roughly the same. It can handle equality, range queries, and also pattern matching operators using like. When it comes to hash indexes to 32-bit hash code derived from the value of indexed column. Hence, such indexes can only handle simple equality comparisons. With respect to GIN, also called as generalized inverted indexes, are useful for data values that contains multiple component values such as arrays, range, Json, and also they can or full text. And when it comes to gist, for example, gist also called as generalized search tree, these indexes allow you to build a general balanced tree structure, and they can be used for operations beyond equality and range predicates. So they are useful on data types such as geometric data, or even as well as, if you want to use it for full text search. And SPGIST, which is also called space partitioned gist index, it's similar to gist, but it uses a partitioned search tree to index non-balanced data structures. Thus, it simplifies the search and insert operations. And finally, the brin indexes, also called as block range indexes, they store summaries about the values stored in consecutive physical block ranges of a table column. So brin is much smaller and less costly to maintain in comparison with a B-tree index. brin allows the use of an index on a very large table that would previously be impractical using a B-tree without horizontal partitioning. So in addition to these indexes, Postgres also supports index types such as partial indexes, expression indexes, also called as function-based indexes in Oracle. Right? So with that, let's now look on to the data types now. PostgreSQL has around 64 base types, and they can be extended for more. When migrating from Oracle, one thing to keep in mind is about numbered data type. Majority of migration tools maps number to numeric. So please check the nature of the data stored in the number data column and map appropriate data type when you're migrating to PostgreSQL. I have an example in the next slide to show the performance implications of using numeric data type for integer values. So in this slide, I have created a test table called T1 and T2 using numeric data type on the left-hand side and using big-int data types on the right-hand side. And there is a very simple natural join performing with a join on C1 column on both the tables on the left and right side. So as you can see here, it took around 2.75 seconds with the numeric type versus 1.9 seconds with the big-int type. So please ensure that you use big-int when migrating Oracle workloads with the number data type that has integer data, which is using sequences, for example, right? So my recommendation would be, as we suggested in DMS, please review Oracle to Aurora PostgreSQL migration Playbook for additional details. It has a lot more details for you and the best practices when you are migrating Oracle workloads to Aurora PostgreSQL, which also applies to Rds PostgreSQL. With that, I'm going to move on to my fifth point, which is dual table. Dual table is a common practice in Oracle and most commonly used in PL/SQL procedures, functions, etc. So when it comes to PostgreSQL, please note that it is an optional, and try not to simulate it unless it is really necessary. And of course, as shown in the example, you can create a view and use that to mark your table in PostgreSQL. So let's move on to the next slide to talk about nulls. Another one is the nulls behavior in PostgreSQL versus Oracle. It's very important. Oracle databases treat null and empty strings as same. So you can use empty strings and nulls interchangeably in any operation in Oracle. However, in PostgreSQL, null means the value is unknown or not given, and an empty string means a string with a zero length. So therefore, null and empty strings are interpreted, represented, and operated differently in PostgreSQL. Concatenating null values within non-null characters results in that character in Oracle, but it's going to result in a null in PostgreSQL as shown in the example. And another thing is, please make sure that you use alias to handle nulls in PostgreSQL. So let's move on to the next slide to talk about synonyms. Synonyms are a way to reference objects by another name or referencing cross-schema objects without fully qualifying them. So that's a common practice in Oracle, even in stored procedures, functions, procedures, and packages, of course. PostgreSQL does not have this feature, but it's possible to accomplish similar behavior using search path. So the search path consists list of schemas to look in order when tables referred by unqualified names. So the first matching table in the search path is taken to be the one wanted by your query. So the next one I'm going to talk about is the sequences. In Oracle, when a sequence cache is generated, all sessions can access the same cache. However, in PostgreSQL, each session gets its own cache. So that's the fundamental difference when it comes to PostgreSQL. So this example, which I've given in the slide, clearly demonstrates the difference. In Oracle, as you can see, session 2, when you generate a sequence next val, immediately after session 1, you're getting a consecutive value, right? 1 and 2. But when it comes to Postgres, every session process has its own cache. So the first session, when it generates, it's going to cache the first 100 values. And the session 2, when it tries to generate the sequence next value, it's going to start with 101 and going to cache next of 101 to 100 and 200 values in the session 2. So now let's now look into exceptions. So it's a common practice in Oracle to ensure proper transaction management and error handling using exceptions part of stored procedures, functions, packages, and of course the anonymous PL/SQL blocks. That's how we keep the corner cases, runtime failures, and unexpected user input from creating a bad data. Most migration tools simply translate the code into PL/PG/SQL. PostgreSQL also handles runtime errors gracefully and gives the reliable error codes and messages to calling code, such as PL/PG/SQL or application when directly called. But there are a couple of differences in the way PostgreSQL deals with these internally versus how Oracle behaves that require changes to application code or design. First, PostgreSQL does not allow transaction control inside PL/PG/SQL. You cannot commit or roll back a transaction within a stored procedure. So the application that calls the stored procedure must perform transaction management, starting and committing or rolling back the transaction. The stored procedure executes within that calling transaction context. The second one is runtime error handling through exceptions. Please note that Not all Oracle exceptions are PostgreSQL exceptions. For example, no data found, too many rows are not PLPG SQL exceptions. So if you want to get the similar behavior, use strict to get similar behavior like Oracle in PLPG SQL. Most importantly, exception handling blocks automatically create subtransactions, or what we call it as save points. It automatically rolls back to a save point when exception occurs. Please note that these exception blocks, and because they create subtransactions, they are very expensive when it comes to PostgreSQL. Excessive use of subtransactions could cause performance regression in PostgreSQL, as every subtransaction has to generate a transaction ID, and as a result, vacuum has to work harder, and that's going to cause performance regression if there are a large number of concurrent sessions performing excessive subtransactions. So when migrating your workload, try to remove unnecessary exception handlers in PostgreSQL. So in the next slide, it's going to talk about a few design guidelines when you're migrating your workloads. PostgreSQL features declarative partitioning for horizontal partitioning a table if you want to scale out your workloads of a table. So you can use pgpartman extension for automatic partition management, and make sure that you keep the number of partitions as a best practice to below 100 as a best practice in PostgreSQL. Please keep in mind that PostgreSQL does not support fast refresh option on materialized views. Full refresh is supported, and you can use pgcron extension for performing automatic periodic refresh on these materialized views. If your application is using temporary tables, global temporary tables in Oracle, so PostgreSQL also has temporary tables, and they are valid only for the current session in PostgreSQL. That means they are created, used within that session, and dropped when that session disconnects. Therefore, the other session don't have access to these temporary tables created on other sessions. Reduce foreign key constraints use in PostgreSQL as a best practice. As discussed in previous slide, please ensure that you reduce the usage of subtransactions. Most of the ORM tools that turns this feature on. So please check and turn it off if not required. PostgreSQL does not have key buffer cache like Oracle, but of course you can use extension like pgprevorm to cache database object blocks. And other guidelines for Jdbc. Jdbc is a PostgreSQL driver for Java. It's an open source Jdbc driver written in pure Java type 4 and communicates in PostgreSQL native network protocol. So because of this, the driver is platform independent. Once compiled, the driver can be used on any system. So I'll take a few seconds to touch few key connection properties in Jdbc driver, starting with prepare threshold, which defaults to 5, means driver automatically prepares the statements if the query is executed at least 5 times. So if you are planning to use database connection pools like RDS proxy or PG bouncer, which is a server-side database connection pooler, consider setting this to 0 if you intend to use transaction-bound connection pooling mode. Also, utilizing client-based connection pooling in application and database connection pool solutions, such as managed RDS proxy or PG bouncer, would reduce overhead on the database, and as a best practice, I would highly recommend. And the next parameter is host recheck seconds, which defaults to 10 seconds. It is for the number of seconds between checking the status, whether the whole node is running in read or write status. So you can use this for connection failover tuning. With Oracle, the default Jdbc fetch size is 10 rows, and PostgreSQL uses the default of 0, means the default value from the driver properties is used, which means loading the entire result set into the memory. So please consider setting it to appropriate value when querying very large datasets. So consider using bulk inserts or updates when you're using Jdbc such as execute batch to improve performance. And finally, the autosave, which I talked about. It's very, very important. And it specifies what the driver should do if a query fails. So please consider using the default value autosave to never if you are not intended to use the subtransactions. PostgreSQL does not scale well on the large concurrent workloads if you are using autosave always mode. So with that, I'll now hand it over to Joe to talk about various programs that can help you to migrate your workloads. Back to you, Joe.
Thank you, Krishna. Let's talk about the programs and partners that can help you migrate from Rds Oracle to Rds PostgreSQL or Aurora PostgreSQL. We observed some customers had challenges due to the complexity of migrations. The scope of the task is broad. You need to understand the source database, the target database, the migration tools, and also understand the application. As a result, AWS came out with a program called Database Freedom. The Database Freedom program encompasses programs, AWS experts, and the innovative tools we covered, as well as training and recommending partners who can help you with your migrations. The Database Migration Accelerator program supports migrations from Oracle or SQL Server to Amazon Aurora or Amazon RDS for PostgreSQL or MySQL. Amazon DMA allows customers to pay after the migration is complete, thereby reducing the risk of cost overruns. There are many AWS partners that can help you move from commercial database engines to RDS PostgreSQL or Aurora PostgreSQL. Talk to your Database Freedom team representative or visit the AWS Partner Network site for more details. In addition to programs and partners, AWS enables you to work on your own by providing blogs, a rich documentation set, and training workshops. All the links on the previous slides, as well as additional links, can be found on this reference slide. Work with your account team to set up an RDS Postgres or Aurora Postgres workshop for hands-on experience. On behalf of Krishna and myself, thank you for attending today's session. We will now open up to the floor for Q&A.